The art of comparison. Let us compare two distinct things, AB and AC. We find that AC is not to AB as AB is to AC. They are very different. AB is said to be greater than AC, and AC is said to be less than AB. They are just different, and there does not seem to be anything else we can do with them. Given two, and only two things, it seems that all we can do is determine if they are equal to each other or not. And if they are not equal to each other, one is less than the other. We can name one as less than the other, and name one greater than the other. Let us make some assertion D of AB. We can still make judgments as to equal, greater, and lesser, but now, if we remember that what we see, in a sense parallel what we think, after all, how do we know, if not by some parallel, that one is greater and one lesser than the other? Parallel is an implied given. Anyone with a brain can arrive at that fact. We can now discover mathematics, the art of information processing, by using what we have. We are going to use a parallel line as a means of paralleling perception with conception. In short, one parallel is perceptible, but the other has to be added intelligibly. By connecting D to C, we now have a line, which we can use as a parallel to find E, and now we have as AD is to AB, so too is AC to AE. In other words, we can now make anything we want to some particular scale. The parallel allows us to make two things proportional. Simple-minded so-called mathematicians, who claim that one can produce mathematics without this fact, are too dim-witted to realize that they have contradicted themselves. Plato did suggest that one might learn this by comparing the fingers of their own hand. Any two fingers are either equal, or one is greater than the other. When you consider three fingers, well, then you can discover all information processing. Let us proceed and discover some basics. Let us repeat what we did, but from what is called a different perspective. Again, we have AD is to AB as AE is to AC, but we also had as AD is to AB, so too is AC to E. Now we can say in one case, we are adding to AC, in the other subtracting from AC. We have discovered addition and subtraction. We can also call this phenomenon induction, when we are working outside of AC, thus adding to the original, and deduction when we are working within what we already have of AC. Let us assume that this excites us so much, we want to recursively apply what we have just done with AC, and see if we can discover more. We draw another segment behind AB, but in order to continue to work with our given AC, we have to transfer the point T to it. We do not want to simply repeat what we did with D, we want to interact T and D to find out what we can. We are going to use D and D to create F in this manner. Let us examine the result. To aid us in examining the result, we are going to redraw the figure so that we are not starting off with relative proportions but with discrete portions of AC. What we are saying is that line AC will be made arithmetic, with numbers, while AB algebraic, with letters. We will construct two more algebraic names A and B. Now, we have mapped algebraic names to arithmetic, or as above, we have scaled them. Where arithmetic names are composed by place value notation with 10 symbols, algebraic names can be any combination one likes. Arithmetic names are absolute, where algebraic names are relative. Now, stories are made up to make things appear different from what they are, but we will leave storytellers out of the picture here. In the above we say as A is to Z so too 1 is to 3 and as B is to Z so 2 is 1 to 7. Now we can perform operations using an interaction between the absolute and relative. With our first mathematical operation, we find addition. We have found that as C is to Z, so too is 1 to 10, so we can go ahead and produce 10 in the arithmetic naming convention. If is to Z as 1 is to 3, and if B is to Z as 1 is to 7, and C is to Z as 1 is to 10, then C is to 3 plus 7 equals 10. In our second mathematical operation, we find subtraction. Slash. If is to z as 1 is to 2, and if b is to z as 1 is to 6, and if c is to z as 1 is to 4, then c is to z as 6 minus 2 equals 4, and we can go ahead and draw the parallel from c. Slash. In our third mathematical operation, we discover multiplication. Slash. As a is to z, so 2 is 1 to 4, as b is to z, so 2 is 1 to 2, and as c is to z, so 2 is 2 times 4 equals 8, and like before, we can draw that into the figure now. Slash. 3 down, 1 to go for elementary math. The next and last is division. Slash. As a is to z, so 2 is 1 to 6, as b is to z, so 2 is 1 to 2, and as c is to z, so 2 is 6 divided by 2 equals 3, and again, we can go ahead and write it in. Slash. Now that we have paired arithmetic with algebra, let us repeat it, but this time wholly algebraically. Slash. We see, from the start, that the horizontal line is the reciprocal of the vertical line. We will eventually learn that 0 is the reciprocal of infinity. Addition. Slash. D plus E equals F. Subtraction. Slash. E minus D equals F. Multiplication. Slash. D times E equals F. Division. Slash. E divided by D equals F. Performing operations in pure algebra emphasizes the operations, making the notation more compact. The traditional method of teaching operations on names promotes mythological stories by people who think they know the topic better than they are actually demonstrating. There are no operations using names, which changes the original convention of names used. We name limits and we name relative differences between the relatives. We are never actually naming the thing in of itself, and to speak as if we do, we are not actually literate, and we are promoting forgetfulness and illiteracy in what we can actually name and are actually doing with them. No name of an element of a thing can possibly be predicated of another element of a thing. A definition, as Plato pointed out, is a combination of names. A noun equated to a predicate pair of relative and correlative, is actually denoting the noun as a correlative, or container of two intelligible distinctions, noun and verb. Nouns parse verbs, and verbs are parsed by nouns. Just as a point is that which has no part, a noun is that which has no relative difference. What can be predicated of any noun is what that noun, as a container, names, relatives and correlatives. Keep it simple, direct, and one can make up countless word stories using just these four mathematical operations. These word stories will teach how to pair common grammar with arithmetic, algebraic, naming conventions and logical concepts put correctly into common grammar. It will help remove the common obfuscation in textbooks, along with allowing children how to think clearly without the mythos commonly perpetrated in information processing. Stop educators from demanding the dissociation of fact from what is obviously perceptible. Stop educationally enforced schizophrenia. It is wholly a pathetic situation today, with crackpots claiming they can tell you all about the universe, when they cannot even tell you, correctly, how to use a simple pencil. Educational systems around the world are producing armies of self-inflated crackpots, schizophrenic crackpots.
False words are not only evil in themselves, but they infect the mind with evil. Phaedo by Plato,